adhesive solutions for perovskite-based and organic photovoltaic applications. So over to you, Lena.
Perfect. Okay. Yeah, welcome to my talk. My name is Lena Reinke. I'm from Panacool, and today we will talk about perovskite-based and organic photovoltaic applications. Panacool's headquarters are located in Steinbach-Taunus, which is next to Frankfurt, so in the middle of Germany. And we are having roughly 100 people working for Panacool on our headquarters here in Steinbach. And we are concentrating on industrial adhesives and also take a deeper look into those adhesives for OPV and perovskite applications. As you may all know, the state of the art is like crystalline silicon, which is used in PV panels that are installed on many rooftops nowadays. But as often flexibilized devices are required, and also indoor applications are coming up more and more. We need potential alternatives, which are in the end OPVs and perovskite-based systems. And for liquid adhesive suppliers, it's very interesting to step into this game because we can bring the adhesives, for example, for encapsulation applications. And as we are part of the Höhnle group, we can also bring suitable UV curing equipment to cure those liquid adhesives under barrier foils or glass substrates. Yeah, there are two main or major bonding tasks that we are taking a deeper look into. It's the foil lamination and the contacting of the OPV or perovskite cells. We will start with the part for the foil lamination. In this case, we recommend our Vitralit line adhesives, as these are always UV curing adhesives, which is a fast and efficient method to cure the liquid adhesive. And in the end, we can use two different main chemistries, which is like epoxy-based chemistry and an acrylate-based one. And but in the end, it's really all about the barrier properties of those polymers that we create by curing. And also, as we will use it for flexible devices, it's very important that the adhesive is very flexible in its cured state and also brings a good adhesion to the used barrier foil materials. Also, the compatibility to the PV materials is a big topic, as those are often very sensitive towards highly nucleophilic components in the liquid adhesive, or maybe also radical chemistry. In case of the acrylate chemistry, could be problematic if we see that are maybe also double bonds are included in the active layers of organic photovoltaic cells. What we also always address is that the adhesives are non-toxic, non-CMR labeled, as I think if you really have a sustainability, or if you want to help to create a device that will have this sustainability stamp on it, we also need adhesives that are not labeled toxic. And the fast curing via UV light, this is mandatory, I guess. The characteristics, we have many adhesives in our R&D pipe at the moment, and there are like more standard systems that are like more rigid and flexibilized solutions. As you can see here, you can really bend those adhesive samples even if they are really thick, like they are in this video, and you have a really good T-peel strength on PET-based barrier foil materials, and also the barrier properties in form of the WVTR value is comparably good, I would say, especially if you measure at enhanced temperature and rest humidity. This is like an acrylate-based adhesive, and we can reach values that are lower than 20 gram per day in square meter, which is kind of good for an adhesive. And yeah, the elongation at break also is like a parameter on which you can see how flexible the system is, and the TG could also help by estimating this. And the standard systems are way more rigid. And this is, I think this is the reason why the TP strength on the very flexible foil materials is often not that perfect. But the WVTR often is way better than for flexibilized solutions, as you will have a denser cross-linking in the adhesive, and this will help to prevent water molecules to come through this adhesive layer in the end. Yeah, in our labs, the barrier properties are measured via those cups, and the yellow part here is our adhesive layer. This is a cured part of the adhesive, and we fill a desiccant on top of the on the bottom of this cup, and then weigh the cup before and after it was stored under enhanced temperature and defined rest humidity in the climate chamber, and then we can see how big or how small the WVTR value is. The adhesion strength is measured on our machine here, and especially by using flexibilized acrylates, you always see those cohesive failures. This is kind of a nice measurement method here. And for the compatibility, we really need the feedback from our customers that to whom we sample our liquid adhesives, and they test them on their active materials and really measure efficiencies, while we can do first qualitative tests in our labs if the customer wants us to do this and is providing OPV or perovskite materials, and then we can check if there is a direct discoloration. Then this sample we won't consider to ship a sample that is not passing a qualitative compatibility test, which would save time in the end. There are many very important requirements that we try to bring in a good balance, and I would say we are on a good path. And we are always happy if there are people and companies that are interested in testing those adhesives really together with us to find out if the adhesives that we are working on are really fitting into this OPV and perovskite technologies. Yeah, Kasia, if you could go further, right? Yep. On the other hand, we also have conductive adhesives that can be used for contacting bonding tasks on perovskite OPV-based materials. And yeah, exactly. Here we have our Electrolit product line. Those are electrically and or thermally conductive adhesives, but in this case we will concentrate on the electrically conductive adhesives for those contacting issues. Exactly, and here the requirements are mainly the conductivity. We also need a certain flexibility, or I would say, also bendability. And it's always good to have a one-part epoxy, as this is easier in the application for the customer in the end. And low curing temperature is always like good for those applications, as the materials can be sensitive towards high temperatures. And also here a non-CMR, non-toxic raw materials are mandatory. Yeah, in this case, we also have like more rigid and more flexibilized solutions, whereas the flexibilized ones are really preferred in those applications right here. So if the viscosity is about 10,000 MPa for this adhesive, which is often suitable, you can also jet this adhesive, and you can see that the adhesive is quite soft because of its shore hardness and the lower TG in comparison to a very rigid standard system.
Maybe 2 more minutes.
Yeah. And exactly, the resistivity is measured between, we measure the electrical voltage between 2 tips, and then we have the surface resistivity, which is then calculated to the volume resistivity. And the flexibility measurements are like qualitatively done by hand. You can also use a microscope to see if there are like cracks in your surface after bending and stretching the adhesive. And yeah, shore hardness, TG, this is all very standard and classical. And also here we need to see that the silver content, flexibility, and adhesion, that all those parameters are balanced out. And I guess I'm finished now.
All right, so a round of applause for Lena Reinke, and we have a few questions. First of all, will the adhesion layers degrade at high temperatures?
This really depends on the temperature that is applied. So if the temperature will go up to, I don't know, 200 degrees or something, it will definitely cause problems. But what we often test is like 85 testings over 1,000 hours. And our latest acrylic sample showed good values even after 1,000 hours of an 85 test.
What is the sheet resistance of these materials?
The sheet resistance, I can't really tell you. This is something that I need to look up together with our R&D. So if this is, if you want to, you can also write an email to me and we can check with our R&D.
And final question, what is the final thickness of the film after UV thermal curing for perovskite applications?
This is also, really depends on the customer. So if the customer wants to apply a 25 micron thickness, this is possible with our adhesives, as well as, I would say, 100 microns would also be fine. So the curing of the adhesives is tested in our labs always for layer thicknesses between 25 and 100 micrometers. Could be even higher in thickness, but I think this is for most customers not relevant because they want to avoid to use too much adhesive.
All right, thank you once again, Lena. Great talk.